Hello dear students, in numerical differentiation, today we will discuss the Newton's and a backward interpolation formula. This is a lecture number 2. We have already discussed Newton forward interpolations formula with respect to numerical differentiation in lecture number 1, and now today we will discuss Newton's backward interpolations formula. So this is the lecture number 2. We start from problem. This is the problem given that the value of x is 0.1, 0.2, 0.3, 0.40 and the values of y equal to fx is 1.10517. The second values of y is 1.22140. Third values of y is 1.34986 and the last values of y is 1.49182. Find the values of dy by dx and d2y by dx square at x equal to 0.4. This is the problem of Newton's backward interpolations formula. See here the values with respect to x equal to 0.4. That means, see in problem of the table x equal to 0.4 in the last. So since the derivatives are required near and the end of the table, therefore we shall use Newton backward formula. We have already discussed when we start at driving the point of dy by dx, d2y by dx square at suppose x equal to 0.1. That means we use Newton forward formula. When we have given the values nearby end of the result of x, that means 0.4, 0.3, that means we start the Newton's backward formula. So here the value at x equal to 0.4, that means we use the formula Newton's backward formula. So here is the table of Newton backward formula. This is the operator of Newton backward formula. This is the operator of backward. The values of y is like this: 0.1, 0.2, 0.3 and 0.4, and the values of y is 1.10517, 1.22140, and the third values of y is 1.34986, and the last values of y is 1.49182, that is yn. This is the last value of yn, and this is the first values of y. That means in lecture number 1 we have already discussed the first value of y is denoted by y0, that means initial value of values of y. Here the last values of y is 1.49182, that means the last value of y is yn. It is denoted by yn. So write down the indication marks, that is yn. Now backward difference of the first table is del of yn is first your difference between these two. So subtract 1.22140 minus 1.10517. It becomes 0.11628. So first you subtract this value and write down in the middle. Similarly, the same process in the next two. Subtract between these two and write down in the middle. Subtract between these two and write down in the middle. So this is the first back difference result, that is yn. Now the next del square yn is again difference between these two and write down in the middle. This is 0.01223, and the next difference between these two and write down in the middle. This is 0.01350. Again the last table is del cube yn, again difference between these two and write down in the middle, that is 0.0027. So this is the backward difference table. Now using Newton backward formula. What is Newton backward formula? Y equal to f of a plus nh plus uh equal to yn plus del of yn plus u plus 1 divided by factorial 2 del square yn plus u plus 1 u plus 2 divided by factorial 3 del cube yn. So this is the formula of Newton backward interpolation formula. Now according to the problem, here h equal to 0.1. What is h? H is the interval. So subtract any two values of y, we will get the value of h, that is h equal to 0.1, and yn is the last term. As I have already discussed, the last value of y, that is yn. Now differentiating equation 1 with respect to u, differentiating equation 1 twice with respect to u, we get, see here, f of a plus nh plus uh. How can we differentiate it? First we differentiate the function, that is, it is denoted by f dash a plus nh plus uh. Then after, the values of f means a plus nh plus uh. Now differentiate these value. So this is 0, it becomes 0 because we differentiate with respect to u, and this value u of h, the value of differentiation of u is 1. So here is h of f dash a plus nh plus uh. So this is the differentiation of left hand side of equation 1. Now the first value of equation 1, this is 0 del of yn plus uh. First you multiply this, and u square plus u. So differentiation of this is 2u plus 1 divided by 2 del square yn. Here I think missing, here is u. So write down the formula yn plus u of del of yn. So put here u. And the third value of the differentiation is, it becomes, first you multiply and then you differentiate, it becomes 3u square plus 6u plus 2 divided by 6 del cube yn. This is the first derivatives of Newton's backward formula. Again we differentiate, and this result with respect to u, it becomes again h squared f double dash a plus nh plus uh. Same differentiation with respect to u means f dash becomes f double dash, and the differentiation of the values of f of a plus nh plus uh is, again it becomes h. So h in previous and h again, it becomes h square f double dash a plus nh plus uh, and this result becomes del square un plus u plus 1 del cube yn. So this is equation number 3rd. So how can we start? First we form the table, and then after using the Newton backward formula, here is Newton formula, again I repeat the all results, y equal to a plus nh plus uh equal to yn plus u of del yn. I think here is missing an u, so put here u of del yn plus u plus 1 divided by factorial 2 del square yn plus u plus 1 u plus 2 divided by factorial 3 del cube yn. This is equation number 1. Now here h equal to 0.1, and what is yn? Yn with the last term of y. So differentiate equation 1 with respect to u twice, and we get the equation 2 and equation 3. Then after putting u equal to 0, what is u? U is x minus x0 divided by h is called u. So it becomes 0. And what is h? H equal to 0.1, h is interval, and a plus nh plus uh is the last term of y series, that is 0.4. Now putting all these value in equation 2 and equation 3, we get f dash of 0.4, f dash means dy by dx at x equal to 0.4 becomes 1 by h. H means 0.1 of this value. It becomes from equation number 2, and the result is 1.4913. Then after we put u equal to 0 and h equal to 0.1 and a plus nh plus uh equal to 0.4 in equation third, and we get f double dash 0.4 equal to del square y divided by dx square at x equal to 0.4 becomes 1 by 0.01 of this value. So the final result is 1.4770. So this is the process of, again I repeat the all things. This is the problem. First you drive the tabulations of Newton backward, then after use the formula of Newton backward, and then differentiate twice with respect to u, and we get the equation 2 and equation third. Then after we put the value of u equal to 0 and h equal to 0.1 and a plus nh plus uh equal to 0.4 in equation 2 and 3. From equation 2 we get the first derivatives, and from equation third we get the second derivatives. So this is the process of this is the process of numerical differentiation by Newton backward difference formula. Thank you.